Hello, my joshful, energetic students preparing for Olympiad exams, JEE exam, NEET exam, and students who are just learning physics for the passion of it. Now, when you prepare for exams or you just want to learn physics, the best way is to learn conceptually, and unfortunately, there are inefficient methods employed to teach physics. And I really want to make things simple here. And in that, with that ideology, I have started this series on Noodle Chopstick. Now, what is this series about? Obviously, when you face a situation in real life or in academics, there are two ways to deal with it. One is the noodle method and the other one is chopstick method. Now this noodle method is very messy, I would say. And this one is so straightforward, easy to understand. Everything is so beautifully from point A to point B. I would rather go chopstick method rather than noodle method because noodle method is definitely very confusing, lengthy, error prone, and difficult to understand. And surprisingly, many teachers go the noodle method. And always my thought has been that there might be two reasons for that. One is that when those teachers were students themselves, they learned it in a difficult to understand manner. They learned it with the noodle method and they did not explore other options out there. Or maybe they're aware of the other options, but they do not want to reveal them to you because maybe, and just my thought here, maybe they want you to think it's a rocket science. And had you not come to that teacher, you would have never understood. So self-study is impossible because physics is difficult. No, that doesn't happen. The self-study method is the best method to learn physics. But anyways, we'll stick to the chopstick method because that's the way to go. Now, my name is Bhavdeep Sethi. With this ideology of teaching physics in a simplified manner, I have been converting a lot of physics haters into physics lovers. And I always say, go out in the nature, explore nature, and you will learn physics. Nature is the best teacher out there. So in today's series of Noodle Chopstick, we are going to look at pseudo force. Pseudo force is very helpful force. It's a pseudo, I mean, it's fictitious force, but it's so helpful that we have to use it. Unfortunately, I have seen students getting confused with this because maybe they have been taught in a very inefficient manner. So first of all, what is pseudo? If I go to dictionary and look at the meaning of this word, it says not genuine, false, or pretended. And that's exactly what this force is. It is not a real force, it's imagination. Nobody is applying this force. See, forces are applied by known entities or known reasons. I mean, I know I'm falling short on words here, but forces are applied by maybe gravity. Forces are applied by charges. Forces, if there is force is applied by me pushing something. Force is applied by surface friction. Forces are applied by intermolecular attractions, right? So we are going to talk about forces in upcoming videos in a simplified way, but the point is this is a force that is not applied by anybody, but it's just an imagination, and that helps a lot. So let's understand what this is all about. And first of all, why do we need it? See, the thing is, if there is an observer that is accelerating, not the object, the observer it's himself or herself, if let's say there's an observer accelerating, that observer cannot use F equals ma. And for that matter, it's basically the observer cannot use Newton laws, many of the Newton laws. And can you even imagine a world where you cannot use Newtonian physics? But that's a fact. I mean, if the observer is accelerating, all these Newton laws will fail. But to help us use them, pseudo force will come into play. So if you are in a situation, let's say you are the observer and you are accelerating, you will not be able to use any of these Newton laws, especially F equals ma. But you want to use it because life without this law or this equation is unimaginable. So you bring in the pseudo force into play and now you can use it. So do you understand the significance, the importance of this pseudo force? So how does it even work? Let's take a situation and see why F equals ma will fail. So let's think about, let's say there is something, I don't know, maybe a train. Yeah, let's take a train. I don't know how to draw a train. And again, this is not an art class, and I'm not an artist, by the way. So I'm just trying my best. So let's say it's some rails on wheels, maybe car, truck, something, right? And then there is an observer sitting inside of it. Sitting, standing, doesn't matter. So there is somebody inside this train. And let's say there is another observer here. And let's call this observer Nilu, right? Nilu. And maybe Pilu there or whatever, Mr. White, Mr. Blue. So now there are two observers here. Now let's say there is an object. Let's say there is an object. Think of this object as tree. So this is a tree, and let's assume the tree is 1000 kilograms. Taking a situation here, so there's a train, there's a person standing outside, somebody is inside the train, and there's a tree of 1000 kilograms. Now let's talk about this person here, Nilu, and Nilu is looking at the tree, analyzing along the x-axis, not the y-axis, just the x-axis. And we know these axes are independent of each other. So when we are analyzing x-axis, y-axis or z-axis doesn't come into play. Now Nilu says, I know nobody is applying any force on this tree. Very simple situation. There is no force on the tree, and for that matter, there is no acceleration. So Nilu analyzes the situation and says, F equals ma. Now, because there is no net force in the horizontal direction, I know there's a weight and normal force in the vertical direction, but we are talking about x-axis. So Nilu says there is zero force, and that is why there is zero acceleration. And this equation looks good to me. Nilu says I can use this equation because nobody is applying the force, and that is why there's no acceleration. Now let's take it from the perspective of Mr. White. Let's say the train is stationary, the vehicle is stationary. It's the same situation. Mr. White will say, okay, no force, no acceleration. And even if the train or the vehicle is moving with a uniform velocity, there's no acceleration, so there's no force, there's no acceleration. Nothing changes, even if this is moving with, let's say, a velocity of 2 meters per second. Nothing changes. I mean, it will say, okay, it's going back. So again, think about this. If the vehicle is moving at 2 meters per second, Mr. White is moving with 2 meters per second. Mr. White is the observer. Motion is relative. Mr. White will say, I am not moving. Tree is moving back. Nilu is moving back. Is that clear to you? Please write in the chat box if that part is clear. From this observer perspective, observer says, I am not moving. The tree is moving back, the mountains, the houses, everything is moving back because that's the whole point of motion. Motion is relative. And Mr. White says, okay, I'm not moving. Tree is moving back with a uniform speed of 2 meters per second. But again, the equation still is valid because it says F equals ma, and it says, okay, I know there is no force, so there is no acceleration. It's just that this vanishes and this is 2 meters per second. All looks still good. The only fact is that the tree is moving back, which from our day-to-day notion of non-living things, by the way, tree is living, but our notion of tree not moving doesn't fit there. But still, I mean, from physics perspective, this is completely working, and even the equation is working. But things will be different if let's say we change the situation. We say, what if the vehicle is now accelerating with 2 meters per second square? So note, it is accelerating, not uniform motion, it is accelerating. Now the same thing, the observer says, okay, I am the observer, I am just standing still, I'm not moving, I'm not accelerating, nothing. And for me, from my perspective, this doesn't work. Actually, the tree is accelerating backwards with 2 meters per second square. Because think about it, after 1 second, this person is moving with 2 meters per second. Says, no, tree is going back with 2 meters per second. After another second, this person is going with 4 meters per second. He says, no, the tree has started to move back with 4 meters per second. So this person says, the tree is accelerating back with 2 meters per second square. Now this doesn't work because think about it, this person knows right? There is no force. Obviously, I don't see anybody applying a force in the along the x-axis. So force is 0, mass is 1000, acceleration is -2. Wow, what's going on here? The equation is failing. Think about this. The person says, I know there's nobody applying a force, but I can see that the tree is going back with 2 meters per second square. It's a very simple situation just to illustrate you that things will fail if as soon as the observer starts to accelerate, observer is not even able to use the simple equation F equals ma. It fails, completely fails. But we want the person to be able to use. And this is where the fictitious force or the pseudo force comes into play. And I'm going to solve a JEE question that you will see how it can be simplified using the concept of pseudo force. But for now, what do? I tell this person, because you are accelerating, you cannot use this equation unless you visualize a force acting on the tree. And that force is the pseudo force. And how much is that force? The pseudo force is equal to the mass of the object. Which object? Whatever object you're trying to analyze. Mr. White, you're trying to analyze tree, then take the mass of the tree, multiply that by the negative of the acceleration of the frame of reference or the observer. Let me write observer here, or the frame of reference. So what you do is you take the mass of the object you're analyzing, multiply that mass with the negative acceleration of the observer. Acceleration of the observer was 2, negative acceleration is 2 here. So 1000 times 2, 2000 newtons of backward force you apply on this tree. You visualize. Who is applying this force? Nobody. It's just a visualization. It's just a mathematical tool. It's just tool. That's it. So we say, okay, now if you want to analyze this, you have to apply a force which is a fictitious force nobody is applying, but you visualize that. Now you can use it, because what happens now is you say, okay, discard this equation, now analyze. It says, oh, Mr. White says, oh, there's a -2000 force, and then I write mass of the tree times -2. Wow, F is equal to mass times acceleration. It is working. Let's look at another situation where you will find a better understanding of this. So let's say there is a lift or an elevator, whatever you want to call it. So let's say there is a lift or an elevator, and let us say there is a weighing machine inside. Now, first of all, you have to understand that weighing machines do not know your weight. Weighing machines just tell you the normal force. Now, most of the cases, the normal force is equal to the weight, and that's why you get the reading of your weight. But honestly, weighing machines don't know anything about your weight. They don't know how much you weigh, how much is your mass, how many parathas did you eat, how much is your weight. They don't know anything. All they know is how much is the normal force. So let's say this is the green weighing machine, and let's say there is a box sitting on it. So let's say there is a box on top of it, and let's say the box is 20 kilograms. So let's write this is a 20 kilograms of box, and let us say somebody, let's say Mr. White is analyzing. Mr. White will be inside, so let's say Nilu. So Nilu is analyzing the situation. Nilu says, okay, I will draw the free body diagram of this, and I know gravity is pulling it down with 200 newtons of force, and there has to be normal reaction force. That Nilu says, I don't know. As of now, I don't know, but I know this is 200 newtons down because gravity will be 20 times the G. G is 9.81, 9.8 or 10, doesn't really matter. So 200 newtons reaction force upwards. And Nilu says, let me write the equation F equals ma. So F is taking upward as positive. R minus 200 is equal to mass is 20 times acceleration. Nilu says, wait, there's no acceleration. The lift is not moving. So it says, oh, 0. So Nilu says, okay, R is 200 newtons. Normal reaction is 200. Now, because in our day-to-day language or day-to-day conversations, nobody understands newtons. We talk about kilograms. So what weighing machine will say, okay, I know 200 newtons is the reaction. I'll divide it by 10 and I will give you a reading of 20. But remember, this 20 is not coming because of this thingy. 20 is coming because of the reaction force. Okay, cool. Things look good. And then we make Mr. White inside the lift. So Mr. White is inside the lift and Mr. White says, oh, this is the same thing. So Mr. White says, okay, from my perspective, I can see 200 newtons down. Good. Mr. White says, okay, some reaction force up. Good. Now look at this. So Mr. White does the same thing and Mr. White says, okay, R minus 200 is equal to mass times acceleration and says, okay, there's no acceleration. So yeah, good. So reaction force is 200 and this is 20. So both of them are agreeing at this point, right? This equation is working. But now let's change the situation. Let's say the lift starts to go up with 2 meters per second square. 2 meters per second. It is accelerating. It's not just moving with a uniform speed. It is 2 meters per second square of acceleration. So Neelu says, oh, I see the lift is going up with 2 meters per second square. I will have to rearrange all this thing. So it says, okay, this is all good. But then Neelu says, oh, wait, there is an acceleration of 2 meters per second square here. So I will change this. I'll say R going up minus 200 is mass times, oh, let me make the change here. So Neelu says, I'll write 2 there because it's going up with 2 and upward is positive. So it's going with 2 up. And then Neelu says 200 plus 40 is 240. And Neelu says, yeah, and the reaction force is 240 and even the box reading here will be 240 divided by 10 and it will come out to be 24. And that actually you might have experienced when you are inside the lift and lift starts to go up with an acceleration. You will notice that you feel like more weight, right? So 24, and it's understandable. 20 kg of box sitting on a lift going up 2 meters per second square. The reading has changed to 24, and Neelu says, "Yeah, I understand this. Completely understand. F equals ma is explaining why this reading is 24." Now let's talk from the perspective of Mr. White. If the reading is 24, this is a glass elevator or a glass lift. Neelu sees 24. Mr. White will also see 24, obviously, because the reading is reading. It doesn't matter. But now Mr. White is analyzing the situation. Mr. White says, okay, my free body diagram says 200 down because gravity pulls it down. There's near normal reaction up. But wait, Mr. White says there is no acceleration. The box is sitting right there. See, the whole thing is moving up. From Mr. White perspective, box वहीं पर था, वहीं है, वहीं रह गया. Nothing is changing now. So box is not moving, box is not accelerating, nothing. So Mr. White says acceleration is still zero. What's going on? Suddenly, this is failing because as per Mr. White's calculation, the reading should be 200 divided by 10, which is 20. And Mr. White said, what happened just now? Nothing has changed. The box was sitting right there on the machine. And suddenly I see the reading change from 20 to 24. Mr. White is not able to understand that. And the reason for that is Mr. White is now accelerating. See, when the lift is going up, Mr. White, being the observer along with the lift, has to move up with acceleration. So why is this failing? Because an accelerating observer should not be able to use this equation. It will fail unless Mr. White applies the pseudo force. So how much is the pseudo force? Pseudo force, remember, is the mass of the object that is being analyzed multiplied by negative of acceleration of observer. Mass is 20 multiplied by observer going up with 2. We have to multiply with 2 downwards. So 2 times 20, you have to apply a pseudo force of 40 newtons here. Mr. White, you have to apply this force applied by gravity, applied by surface, applied by nobody, just a visualization. Now Mr. White analyzes again and says, okay, reaction force going up, good, minus 200 downwards, good, minus 40 downwards, good, is equal to mass times acceleration. And now this equation is working. So this is the whole point of bringing in pseudo force in play. Let's look at one of the questions from JEE and we will understand it how easily we can solve the questions based on pseudo forces. A block of mass m is kept on an incline of mass uppercase m at an angle of theta. So inclined plane has a mass of uppercase m and the angle of inclination is theta. How much force should be applied to the system to ensure that m remains at rest with respect to m? So let's quickly draw the situation here. So the situation here looks like, okay, this is an inclined plane. Okay, so that's an inclined plane. On the inclined plane is a box, and let's say this box is lowercase m, and this is uppercase m, and this is theta. Now visualize this. Let's say there's no friction because it's not mentioned. We are assuming this is completely a very smooth surface, ideal situation. So gravity is going to pull it down. But think about it. If you accelerate this way, wouldn't this stay there? Because if you push it hard enough, this is not going to go down. And that is the question. The question says, okay, how much force should I apply here so that this remains on the inclined plane? It doesn't move down. Now, the thing is, you can analyze it from two perspectives. One is this, Nilu, analyzing it. Nilu is standing on the ground. Nilu says, okay, let me analyze the forces and then break those forces. And trust me, it's going to be very complicated noodle method to analyze this. Because you'll say, okay, in some time it'll go here, it'll come here, but I'll ensure it is going to be a very noodle method. Now the pseudo forces will make it chopstick method. So what we will do now, we'll ask Mr. White to be on this incline. Mr. White, you sit there and analyze. Now, Mr. White is going to accelerate with the whole system. And let's say the acceleration is A. Because if I am able to find the acceleration, then I can find the force. Because if I know how much should be the acceleration there, then I can multiply that acceleration with the system commas, which is m plus lowercase m, then I get the force. So let's think about from acceleration perspective. So our problem now is how much should be the acceleration in this direction so that this doesn't fall down. That's the question. So if this is Mr. White is going to accelerate with the whole system with A. Now Mr. White has to apply the pseudo force. How much? Mr. White is analyzing this mass. Acceleration is that way. So Mr. White is going to apply a pseudo force in this direction. Now in addition to this pseudo force, there were two more forces. One was the one was the mg, lowercase mg, obviously, because this is the mass we're talking about. So mg going down, and there is a normal force going in this direction. Now, gravity applying this force, inclined plane applying this force, nobody applying this force. This is pseudo force. Nobody. No, who's applying? Nobody is applying. This is just because Mr. White was accelerating. It was an accelerated observer. By the way, this observer is non-inertial frame of reference. I never used that word in this session. I didn't want to confuse you. Maybe we should start talking about it. So accelerated frame of reference will be non-inertial frame of reference or non-Newtonian frame of reference. So Mr. White is non-Newtonian frame of reference. He has to apply this force. Now, once this is applied, Mr. White should see this is in equilibrium. Now Neelu will see the thing is going that way, things are moving. Mr. White says, hold on. He is here. He says nothing is moving. The world is moving backwards. This is stationary. This is in equilibrium. And that makes it easy. Because from this perspective, this is going here, going there, and all that. From Mr. White perspective, the world here is frozen. So these three forces have to balance out each other. This is x-axis, this is y-axis, this is theta, 90 minus theta, theta. So I can break that. So let me break that force with another color here, maybe yellow, if that works. Oh, that works. Okay, that's good. Yellow is visible there. So this is going to be n cos theta and n sin theta. Perfect. So now because everything has to be in equilibrium, these forces have to balance out. So I can say this n sine theta should be ma. So n sine theta going right should be equal to mass times acceleration, and n cos theta, which is going up, has to balance out mg. Simply dividing these two gets rid of normal force, gets rid of mass. So A turns out to be equal to 10 of g, 10 theta times of g. And now you can multiply with the mass uppercase m plus m. So we are saying how much is the force? Force on the system should be the mass of the system times the acceleration of the system, which is equal to mass of the system being this times acceleration, which is g tan theta. And that is the beauty of the pseudo forces, that you are able to analyze this situation in 2 or 3 lines. If you were analyzing from this frame of reference, it would have involved lot of steps. It would have been Noodle method. This makes it the chopstick method. Now, if you like this video, obviously I'm hoping that you're going to like the video, give it a thumbs up, subscribe to the channel if you have not done so, and also share this video with your friends so that they also get benefit of these sessions. And I'm going to be back with more sessions here. But by the way, just a reminder, I have started this Achievers batch for the exam that's coming up on 24th of November 2024. This is going to be classes every day, so you can subscribe to that. I'll write it over here. So this course, even though it says it is 2222, you can get 10% discount here, which will give you for 1999. And based on some of the inputs from the students, I have changed everything. This is not Tuesday, Thursday, it is every day 6 to 7:30 p.m. Every day, Monday through Friday, you will get 15 classes. You can see the link below and purchase this course. It's going to give you the discount. And these classes, we are not going to do any theory here. We are just going to do the PYQs. We'll solve the previous year question papers here. And that's just for the last mile revision. You have worked so hard for NSEP. Now with the exam coming up, it's the time to do previous year question papers and subscribe to this. And if you need any help, I have given my Telegram channel Telegram ID. You can connect with me if you need any clarity on the course. Bhavdeep Singh Sethi, send me a Telegram message. I'll respond to you very soon. Now, if you're looking for a course that is a long-term course, then there is a course which is called Full Physics Mastery 2025. That's a long-term course. It will last till November 2025. So it's divided into 5 modules. Each module has a price of 2,500 times 5 is 12,500. But since we started already, there are 2 modules that are completed. So we are starting third module very soon. You can purchase the third, fourth, and fifth module for 3 times 2,500, and you will get these 2 recordings for free. So first 2 modules are over, but I'll give you the recordings for free. So all you pay is for 3 modules, 1,700 minus this discount BS Pro one. This can be applied to get 750 rupees off. So 6,750 rupees, you get 3 live modules and 2 recorded modules. Okay. Now this is the module wise and description of that. Now, are there any prerequisites? And I always say the prerequisites are your josh and willingness to learn. Your energy is the prerequisite. If you want to attend these classes, you have to be very joshful. Now, surprisingly, we get, not surprisingly, yeah, I would say unfortunately. Unfortunately, newspapers do not publish these results. India has been getting the gold medal, the silver medal, the bronze medal in a lot of Olympiads out there. We are talking about international Olympiads. And it's very unfortunate that newspapers and news publications, they are not covering these. They're covering other news, but not these. These students need their own space in those newspapers. But anyways, I'm hoping that one day you will be part of this. And also, I encourage you to tell your friends about these Olympiad exams. Let everyone be aware about them. Not many people know that we are getting Olympiad medals, and India is making a spot in those, international stages. So I'll see you soon again, and keep up the high josh. So thank you so much.